All right, so today, class, we are going to learn about, we're going to learn about polar coordinates, and I wrote kind of this little blurb myself. Polar coordinates are a point, I think that's a point determined by a ray with an endpoint at the pole, which is like the origin right here, and r theta represents the point r units from the origin and rotated from the polar axis, which is the x-axis, through an angle theta in the counterclockwise direction. If theta is negative, the rotation is clockwise. If r is negative, start the ray in the negative x direction. And then we'll just do some examples. So on this page that I gave you, I have two different polar graphs. They're just kind of, it's really the same thing, divided up into different sections. So let's do it on this polar graph paper that I got here. Oh, great. The Mobi board was off. It's all right. Now it's good. And you connected. All right. So if I were going to graph the point 3, 5 pi over 3, the way I do that is I start here at the origin and I go out 3 units. So usually these things have little division marks. This one's kind of hard because the circles are so small. So 3 represents the radius of one of these circles. So I'd go out 1, 2, 3, and then I'd rotate through an angle of 5 pi over 3. So you have to figure out how to get to 5 pi over 3. Now on here, this is like pi over 12, I believe. This would be pi over 6. This over here would be pi over 4. This would be, so this one here would be pi over 3. And then over here would be pi over 2. So does anyone remember where 5 pi over 3 would be, rotation-wise? In the 4th quadrant, right? Because this is pi over 3, 2 pi over 3 would be 120, 3 pi over 3 would be the same as pi. 4 pi over 3 would put you over here at 240. And then 5 pi over 3 would put you, is that 5 pi over 3? Yeah, 5 pi over 3 would put you right there, which would be the same as 5 pi over 3. Pi over 3 is 60, right? So that would be 300 degrees, okay? So that is that point is this point right there. Questions on that? Easy. So far. Okay, let's be done. No, we're not done yet. Sorry. So I want to erase this line. So there's the first point. Second point, 2 negative pi over 4. You go out 2 on the polar axis, and then you rotate. If r is negative, if theta is negative, you rotate in the negative direction pi over 2. So I would go pi over 4, sorry. So pi over 4 would be right there. Yes?
Okay, but Mr. Leader,
What?
would it make any difference because it's a negative too?
Yeah, I'm going to talk about that one in a minute. This one is 2 negative pi over 4, right? And we'll talk about this one in a second, okay? So then 3, 0, it's just 1, 2, 3. That would be the point 3, 0. Just go straight out 3 and don't rotate it up. Now, we asked negative 2 pi over 4. So it says if r is negative, start the ray in the negative x direction, right? So you would go 1, 2, negative, and then you would rotate through a positive angle of pi over 4. So negative 2 pi over 4, you go out 1, whoops, that's 2, isn't it? Out 2, and then you'd rotate through positive pi over 4, so that point would put you right there. See that? I think. Is that right? Yes? Okay. So that's how you graph polar points. Did I go the wrong? No, that's because this is pi over 6, pi over 4, pi over... Yeah, that works. Right? Now there's other ways to get to these points. So for example, down here, write 3 other polar coordinates r theta for the point 2 pi over 4. So let's go to the point 2 pi over 4, 1, 2 pi over 4, which would put you right there. How else could I get there? There's lots of ways that I could get to that point. I could go backwards and then rotate through that much. I could go out 2 and then I could rotate this way. See that? Or I could go backwards again and then rotate through that way. Or I could go out 2 this way and then I could go around the circle twice to get there. So there's lots of ways, right? 3 other polar coordinates for the point 2 pi over 4. So who could give me another one? What if I call this negative 2? Negative 2, comma what? If I went back 2, how far would I have to rotate through to get that way? Good, okay? Negative 3 pi over 4. Understand that? Because I would have to go backwards 2, and then I'd have to rotate through 3 pi over 4, which is how many degrees? 135 degrees backwards. Yes? Okay? The other way I could get there is going positive 2 and rotating out positive 2 and rotating through the negative direction. How many radians would that be? Negative 7 pi over 6. Negative 7 pi over 4. Pi over 4. And one more way would be, let's see, what if I want to rotate around the circle twice? So I went 1, 2, and I went like this. So if I went 2 and I want to go around the circle once and end up there, what would that be? Pi over 4 plus how many more pi's over 4? Yeah, so it would be pi over 4 plus 8 pi over 4, which would be 9 pi over 4. And there's infinitely many ways to get there, but those would be kind of like the 3 most likely. All right? Yes? Questions? All right. Next thing. Find the point 3 pi and find the other are this same point for so then you'll have questions like this where it says find the point 3 pi over 6. So you're going to go out 3, 1, 2, 3, turn through, is that 3? That's 3, right? Pi over 6, even though it seems like this one, that's pi over 12 because that's half of that. So this is pi over 6 right there. That would be the point 3 pi over 6. And so they say find the other polar coordinates r theta of the same point for which r is bigger than 0. That means r is positive. So r is still going to be 3. And theta is between 2 pi and 4 pi. So in other words, they want you to go like this. Okay? So what would be that point? Just add 2 pi to pi over 6. How many pi's over 6 is 2 pi? Negative 7 pi over 6. Not 7 pi over 6, because a full rotation is 12 pi over 6, right? Because it's 2 pi. 13 pi over 6. Good. So that would be that answer. And then it says, for which r is negative, so negative 3, and theta is a positive number between 0 and 2 pi. So in other words, if I started 1, 2, 3 negative, and then I rotated this way, how far would I have to rotate? I think it would be right that time there. 7 pi over 6, right? Because you're going backwards and then half a circle, which is pi, plus another pi over 6, so that'd be 7 pi over 6. And the next one, r is greater than 0, and theta is a negative angle between 0 and 2 pi. So again, r is 3. And how would I get there? If I go out 1, 2, 3, and I want to rotate through a negative angle, what would that be? Good. Negative 11 pi over 6. It's fun, isn't it? They use this. Anyone know when they use polar coordinates? I'll give you a hint. Radar, yeah, like radar tracking systems, all that kind of stuff. That's how they, that's about how they do it. All right, how do you pause this thing? Can I pause? I can't pause. Uh-oh, my dumb jokes. There must be a way. Okay, anyway, let's go to the next thing. There it is. Can I does this mean pause? Sorry, guys. All right, so, we're past this page. Past this page. Let's get rid of this or hide this. So, conversion from polar to rectangle. So, because in a, if I were to draw a little triangle or a little x and y axis right over here, like that, and if I put in, like, this is r, this is y, and this is x, and this little thing here is your little angle theta, then you can see that the sine of theta is what? Y over r, right? Which means, and the cosine of theta is x over r, which, and then just multiplying through by r, you end up with these two conversions from rectangular. This x, y is called rectangular, and r theta is called polar form. So using the formulas above, convert each point from polar to rectangular and graph each point above the polar and rectangular graphs. So what you have to do is you want to convert this into x comma y. So 6 pi over 6 is going to be 6, r is 6. So 6 cosine pi over 6, comma 6 sine pi over 6. And this is kind of where you have to remember a little bit about the unit circle. Anyone remember what the cosine of pi over 6 or 30 degrees is? Square root of 3 over 2. So you get, this is 6 times root of 3 over 2, comma 6 times, what's the sine of pi over 6? 1/2. So simplifying that, 2 goes into 6 3 times, so that's equal to 3 root 3, comma 3. Questions about that? Got it? And so to get to this point, so I could either go over 6, 1, 2, 3, 4, 5, 6, and rotate through pi over 6, which would give me that point that way. Or I could go out 3 root of 3. 3 root of 3 is about 1.7. And 3 times 1.7 is about 5 point something, right? 5.2, 5.1, 5.2, 5.1. What is it? 5 point something. So I could go out 5 point something. 1. So if I'm on the rectangular grid, 1, 2, 3, 4, 5, and up 3. 1, 2, 3, which puts you in the same spot, right, as going out 6 and rotating through. Yep, easy. It's kind of fun. All right, so same thing with this. I'm going to go negative 4 cosine of negative pi over 4, comma, negative 4 sine of negative pi over 4. And you should remember that cosine of negative pi over 4? Anyone remember? Positive root of 2 over 2. So this would be the same as negative 4 times positive root of 2 over 2, because this is an angle in the fourth quadrant, and remember that cosine's positive there, comma, negative 4 sine of negative pi over 4. Is that negative or positive? Negative, right? So, and that's negative root of 2 over 2. You thought you were all done with all this trig stuff. Still got to know that unit circle. So this becomes negative 2 root 2, comma, positive 2 root 2. Okay? And if I graph that point, this root of 2 is about 1.4. So it's about negative 2.8. So somewhere 1, 2, and up about 2.8. So somewhere around there. Let's see if that makes sense polarly. Back 4, rotate backwards 45 degrees. Would that get me there? Hello? Yeah, it should. Okay, so that's how you do that. Questions? Next thing. There's more? Yes, there is. So converting from rectangular to polar is a little bit trickier since the radius in that little triangle I drew before, x squared plus y squared equals r squared, right? So r is just equal to the square root of x squared plus y squared by the Pythagorean theorem. And theta is the inverse tangent of y over x. But you have to be careful which quadrant you're in, because tangent can be negative in 2 quadrants, right? And this inverse tangent will only give you one answer. So let me show you by example what I mean. So in this case, 2 minus 2, negative 2. So for this one, r is equal to the square root of 2 squared plus negative 2 squared, which is equal to the square root of 8. Yes? Square root of 8, positive. So that's the radius, or 2 root 2, if you prefer. But if I take the inverse tangent of y over x, what's the inverse tangent of negative 1? Negative pi over 4. Okay? You understand that? So this angle that I'm talking about is it's out root of 8, which is 2 root 2, which is about 2.8 something. So you get out like a little less than 3, and then you rotate through negative pi over 4. So in this case, that angle and that point are the same. But you have to be careful, for instance, with the letter B. So let's look at letter B, and we'll look at it. We'll take a picture of it and make it bigger. Place capture. So with this one, so first I want to find r. So in this case, r is the square root of negative 1 squared plus negative root of 3 squared, which is equal to the square root of 1 plus 3, which is equal to square root of 4, which is equal to 2. That's a nice radius to have. But then you want to take the inverse tangent. You get to find theta. You want to take the inverse tangent of negative root of 3 over negative 1, right? Which is the same as the inverse tangent of positive root of 3. And whether you do this on your calculator or by using the unit circle. Does anyone remember what the inverse tangent of positive root of 3 is? Say 60. 60 degrees, okay? Or, I mean, you could have these in degrees too. 60 degrees or pi over 3 radians. But is this point in the first, so if I were to graph that point, go out 1, 2, and rotate through pi over 3, it put me like somewhere over here. Is this point in the first quadrant? Is that point in the first quadrant? No. What quadrant is it in? It's in the third quadrant, -1, negative root of 3. So you're actually talking about this angle from here to here, which is what? Who knows what that angle is? This is pi plus pi over 3, which is 4 pi over 3, right? So you would have to add pi to that because there's two places where inverse tangent are negative. Here, positive. This place and this place. Likewise, there's two places where inverse tangent is negative. So if this is negative, if if x is negative, you're going to be in this quadrant over here. If y is negative, you're going to be in this quadrant. If they're both negative, you're going to be in this quadrant. Understand that? So you got to be careful when you're taking inverse tangents, because inverse tangent is only going to give you this one answer, and it's possible that you could be over here. So in this case, this answer is 2 comma pi over 3 plus pi, which is 4 pi over 3. So that's how you convert it. Or 2 comma 243. Hey, Kevin, wake up. Oh, I could say that on video, and then I could have your dad listen to it. All right. Okay, next thing. I'm not even, 0, 3, that's easy. Okay? What's R? 0. You don't even have to use the formulas. R is not 0. R is the square root of 3 squared, right? So R is just 3. So the point 0, 3, if you think about it, is just up 1, 2, 3 on the polar graph, right? So how many degrees did I rotate through to get there? Do I have to rotate to get to there? 90 degrees. So this is the same as 3 comma 90 degrees, or 3 comma pi over 2.
How did you move like 90 degrees?
Because I know this point is 0 comma 3, right? So another way of getting, if I'm in polar form, another way to get there is to go out 3 and then rotate through 90 degrees, okay? I could have used the formula too and taking the inverse tangent of 3 over 0, which is infinite, but you don't see inverse tangent. Tangent is infinite at multiples of pi over 2, right? So that's where you have to be. So with that one, I just kind of draw a picture of it to figure it out. Okay, this is a little tricky, this one. Transform the equation, and 2 more, and then we'll be done. Capture. So this takes a little bit of algebra. So what you do with this one is kind of a trick, but since we don't really have a formula for r and we have a formula for r squared, what I do with this is I take everything and I multiply it by r. So I take r equals 4 sine theta, and then I multiply that by r. And I multiply both sides by r. Okay? And the reason I do that, so I'm going to write here multiply both sides by r. And when I do that, I get r squared. You're trying to change this into x's and y's, is what you're trying to do. 4r sine theta. Now I have a formula for r squared. What's r squared equal to? R is equal to the square root of x squared plus y squared, but r squared is equal to x squared plus y squared, right? You would take the square root. And what's r sine theta equal to? Hello. Y. What? So now I have an equation in rectangular form. And what they usually want you to do with this is the equation of a circle. And now what you have to do is try to get it looking like the equation of a circle. So I'm going to complete this. First I'm going to subtract y squared from both sides. X squared plus y squared equals, minus 4y equals 0. Now I'm going to complete the square. X squared stays by itself plus y minus 2 squared equals 0 plus something. How much did I add to this when I completed the square on this part right here? How much did I add to that? 4, right? Because y minus, I completed the square, and because I took half of this, you remember doing that? So I added 4 to both sides, so I added 4 to this side, so I need to add 4 to this side. So this here, x squared plus y minus 2 squared equals 4 is the equation of a circle, okay? And does anyone remember what this is? You might have done this in geometry. I'm not sure. Conic oh, you did this last year with conic sections, right? This is the radius squared, and the coordinate. So the equation of a circle, if you remember, is x minus h squared plus y minus k squared equals r squared. Do you remember seeing that? Where this is the radius and hk is a coordinate to the center. So the radius is, so this is a circle. It's a circle with radius what? Radius equals, if r squared is 4, what's the radius? 2. And center where? If h is 0 and k is 2, center is at 0, 2. Okay? So this is the equation of a circle. This r equals 4 sine theta. R equals 4 sine theta is exactly the same as x plus y minus 2 squared equals 4. Now watch this. This is cool. If I have time, I'm going to show you this. Watch. Get your graphing calculator. If you go to mode and you go to this thing down here, boom, 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 up, polar, and then when you go to y equals, did I hit that enter? And if you go to y equals, and it'll give you an r there. So if I go r equals 4 sine, and when you hit the x button, when it's in polar mode, comes up as a theta. And if you hit graph, let's see what happens. My window might not be good. I get that circle that looks like that. And the reason that you can't, your viewing window is not square. So if you go zoom, is that zoom? Zoom square 5. You get a circle with the center at 0, center at 0, 2, right? Which is what I said, right? And a radius of 2. Isn't that cool? That's cool. So, and then the very last thing, going back, last thing, how do I get back there?
Wait, Mr.
Yes.
Is that circle you graphed, is that the thing in rectangular form?
The circle looks the same whichever form you're in. It just, like I graphed it while I was in polar form. Okay, so this equation, where's that equation that I gave you? Where did it go? Uh-oh. Next. What happened? There. Yeah, so either way, if I graph this on a rectangular axis, or if I graph this r equals 4 sine theta on polar axis, I'll get the same thing. And you can do that by plotting points. We'll do that later on in the chapter. Okay? Very last thing, when I get back to my original, is this one. Transform equation 4xy equals 9 from rectangular to polar form. Now at this one, there's not that much you could do. So you just plug in your numbers. So let me just take a picture of it. So with this one, you just plug in, into your formulas. This, if you graphed it, makes hyperbola. I think that looks something like this. But in polar form, I could graph that in polar form as well. And we'll learn more about what the graphs look like later on in the chapter. But for x, if you remember, is our cosine theta. And y, if you remember, is our sine theta. And 9 is just plain old 9. Like that. And then multiplying out a little bit, you get 4r squared 4r squared cosine theta sine theta equals 9. And if you left that, I'd kind of like you to solve it for r, but if you don't, it's okay. But what they do in the book, they kind of get a little bit tricky. They call this r squared. They bring that out in front. R squared times 2. And they do this. 2, they rewrite this as 2 sine theta cosine theta equals 9. And the reason they did that is because this here is equal to something. Anyone remember what that's equal to? 2 sine theta cosine theta? No, that's if you remember that, that's equal to sine of 2 theta. It's just equals 9. And then, so this can be written a little bit more simply as 2r squared sine of 2 theta equals 9. But if you did, if we were on a test and you just wrote it like that, I'm okay with that. You can just leave it. Right? You don't have to go through all that. That's knowing an identity and knowing how to manipulate functions. Any questions? Okay. Let's stop. Stop.